and welcome back to the Ever-Changing World podcast. I'm your host, Ava Zanetti, and have you ever thought about the next World War? Have you thought about where it will take place, what weapons we will be using, and what countries will be involved? Especially now in 2022, where the world is in more disarray than I think any of us have seen in our own lifetimes. After the pandemic, the economy taking a huge hit, inflation on the rise, and the horrible Russian-Ukrainian war, where we haven't seen a major war in Europe for decades. It's really a time where we start to think about these things. And I think in any period of history, we think about if there's going to be a war and what that would look like and how that would impact us. So what is going to be the next World War? Is it going to be the Russian-Ukrainian war that's currently happening? Is NATO going to get involved? And is this going to erupt farther than we have ever even seen? Or will there never be world wars? Is there going to be peace among humanity for once? And are we the generation that is going to see that peace? Are we at a time of prosperity and love? Or are those just fantasies that can never be fulfilled? What I think, and what most people think, is that these wars aren't going to be based off of actual physical weapons. They're not going to be based off of the nuclear bombs that we have, because if a country detonates their nuclear bomb to another country, that other country will detonate their nuclear bomb to their country. And the whole world is dead within minutes. Why would anyone detonate them? They are merely there as a sign of his power, as a sign of saying, I am superior, and I can hurt you. But it doesn't mean I will. So when we aren't fighting wars with things like nuclear bombs, then what are we fighting wars with? And that leads us in today's episode of the war on big data. Yes, wars are no longer going to be fought with horses and swords. They're now going to be fought on the very own device that I'm recording this on. A computer, a mobile device, really anything that can get you access to data. When we look at our world right now, when we see things like Instagram and Facebook and Snapchat and TikTok that are taking all of our data, mining it, and using it for bad in a way. You might not notice this right away, but you may notice it using it to give you particular ads. I think I've touched on this before. But a lot of the times, the social media networks will quite literally listen in onto your conversations, or they will see the things that you stick on the longest. It has an algorithm where it sees how long you stay on a video, how long you stay on a specific site or web page, etc. And what that does, it allows them to know what exact ads they need to target you with so they can make more money. And the world runs on money, so this is no surprise. But it keeps spinning and spinning and spinning, and we don't realize actually how much data we produce as one singular person. We are the product now. I am a product, you are a product, almost 8 billion of us on this earth are a product. Because we tell the companies and corporations what they need to be doing. And if they can track a person, and they can coordinate exactly what they should do in their lives, and when they have that control over us, well, we are really, really just powerless. So, today, I want to talk about big data. Of course, first, explain what big data is, explain, kind of all these different, consistencies with big data. And then I also want to mention kind of this war aspect that I've been touching on this whole introduction, and give you guys an idea of actually how valuable big data is. This is a topic I've wanted to talk about for some time now on the podcast, just because, when I really think about it, and when all of us think about it, When we realize how valuable our data is, how valuable we are as people, I don't think we realize that. I don't think we realize how great of an ad we are as well. We are the ad, and that is quite scary, but as well interesting and thought provoking in the same regard. So, this is really funny. I'm about to read an article on big data, and I just got a I just got a pop-up on one of the websites I was going to use talking about cookies. And cookies allows you to, it basically allows a company to just track where you're going, what websites you're going to, so it can give you more targeted ads and get more data. And I just got this on the site that is talking to me about big data. That was very, very funny. So I'm going to the site, accepted all the cookies, so I guess they can target some ads for me. Okay. So, what exactly is big data? So, here's the description by Oracle. The definition of big data is the data that contains greater variety, arriving in increasing volumes and with more velocity. This is known as the 3 V's. Put simply, big data is larger, more complex data sets, especially from new data sources. These data sets are so voluminous that the traditional data processing software just can't manage them. But these massive volumes of data can be used to address business problems you wouldn't have been able to tackle before. So, what exactly are these 3 V's that this article is speaking about? So first is volume. This is the amount of data. So with big data, you have to process high volumes of low density, unstructured data. This can be the data of unknown value, such as Twitter data feeds, click streams on a web page or mobile app, or sensitive enabled equipment. For some organizations, this might mean tens of terabytes of data. For others, it may be hundreds of petabytes, which is the bigger form. So then velocity is that's the first one is volume. The second one is velocity. This is the fast rate at which data is received and perhaps acted on. Normally, the highest velocity of data streams directly into memory versus being written to disk. Some internet-enabled smart products operate in real time or near real time or require real-time evaluation and action. And now the third V, the final one, is variety. Variety refers to many types of data that are available. Traditional data types are structured and fit neatly in a relational database. With the rise of big data, data comes in within unstructured data types. Unstructured and semi-structured data types, such as text, audio, and video, require additional processing to derive meaning and support metadata. So the 3 ones that we have here are volume, velocity, and variety. These are the big kind of pinnacles to when we're looking at big data, when people are thinking about it, this is what they're looking at. So kind of what's this big truth of big data? So 2 more V's have emerged over the past few years. This has been value and veracity. Data has intrinsic value, but it's no use until that value is discovered. Equally important, how truthful is your data and how much can you rely on it? Today, big data has become capital. Think of the world's biggest tech companies, as I mentioned. A large part of the value they offer comes from their data, which they're constantly analyzing to produce more efficiency and develop new products. Recent technological breakthroughs have exponentially reduced the cost of data storage and compute, making it easier and less expensive to store more data than ever before. With increased volume of big data, now cheaper and more accessible, you can make more accurate and precise business decisions. Finding value in big data isn't only about analyzing it, which is a whole other benefit. It's an entire discovery process that requires insightful analysts, business users, and executives who ask the right questions, recognize patterns, make informed assumptions, and predict behavior. But how did we get here? So a little bit of a backstory, a little bit of a history. So although the concept of big data itself is relatively new, the origins of data sets go back to the 1960s and 70s when the world of data was just started with the first data centers and development of the relational database. Around 2005, people began to realize just how much data users generated through Facebook, YouTube, and other online services. Hadoop, an open source framework created specifically to store and analyze big data sets, was developed that same year. NoSQL has also begun popularity over this time. The development of open source frameworks such as Hadoop and most recently, Spark, was essential for the growth of data because they make big data easier to work with and cheaper to store. In the years since then, the volume of data has skyrocketed. Users are still generating huge amounts of data, but it's not just humans who are doing it. With the advent of the Internet of Things, IoT, more objects and devices are connected through the Internet, gathering data on customer usage patterns and product performance. The emergence of machine learning has produced still more data. While big data has come so far, its useful is only the beginning. Cloud computing has expanded big data possibilities even farther. The cloud offers truly elastic scalability, where developers can simply spin up and hawk clusters in a subset of data. So really, data has been traversing through time. It's been gaining more popularity. Clearly, we can tell since the rise of social media and the internet is huge. So this is big. And there's some benefits with big data. So first, it makes it possible for you to gain more complete answers, and you have more information to gain off of. So when you have someone's complete user interface, you know a lot more about the person than they probably know about themselves. There's all those stories of people, going and finding out they're pregnant, and before they even were, getting ads for being pregnant, and then they actually were pregnant, and it's pretty crazy. As well, more complete answers mean more confidence in the data, which means a completely different approach to tackling problems. So, big data causes. So, we have some causes. I'm just going to name these off since it's going to be a little monotonous. But the causes can be customer experiences, can be fraud and compliance, machine learning, which is a really big topic. Actually, I'll touch on that right now. It's one of the reasons why so we're not able to teach machines instead of program them. So basically, we teach a machine to do something, and then they develop that skill, and then they teach other machines to do it, and then it just keeps going and going and going. So machine learning is huge, as well as operational efficiency and drive innovation. So these are all things that, big data kind of use causes, right? So we also have a lot of challenges, though. So although new technologies have been developed for data storage, data volumes are doubling in size every 2 years. Organizations still keep trouble to keep pace with their data and find ways to effectively store it. But it's not just enough to store the data. Data must be used to value when it depends on the curation. Clean data, or data that's relevant to the client, and organized in a way that enables meaningful analysis, requires a lot of work. Data scientists spend up to 50 to 80% of their time curating and preparing data before it can actually be used. Finally, big data technology is changing at a rapid pace. A few years ago, Apache Hadoop was a popular technology used to handle big data. Then Apache Spark was founded in 2012. Today, a combination of the two frameworks appears to be the best approach. Keeping up with the big data technology is an ongoing challenge. So how does it work? Well, first is integration, which it integrates into the process, and you use these different frameworks to organize the data. Then it manages it, so it requires a lot of storage, and then it analyzes it. It sees where it should be going. So yeah, that's kind of big data, I guess, in a nutshell. You can always read more up on it. And I want to touch on kind of the big hot topics in big data right now. And my websites are just loading right now, so I can't quite speak to this. But while we're waiting here, big data, it really is transforming the world. And you can't really run away from it. There's a lot more jobs and careers opening up in this sector, especially as we're dealing with the problems of how much data we have. It's great that we have a lot, but it's also a lot, right? It's hard to manage. So those are going to be problems that future generations and ourselves are going to have to solve. And it's becoming an issue that seems quite silly right now, but it is very important for what a lot of people do. So, let me just pull up this article here, or maybe this one over here. I don't like a lot of these articles here. Just try to, okay. So, let's talk about big data at war, because you know what, let's just jump into it and get into the meat of the episode. So, during the Iraq War, America's Special Operations Forces demonstrated a remarkable capacity to innovate to accomplish a mission for which they were not prepared. Finding and dismantling Al-Qaeda in Iraq's network of secret cells, which has served as the backbone of insurgency. It did so by developing new operational methods to uncover and eradicate the critical masses of AQI's mid-level commanders and managers of these secret networks. So in Iraq, Secret Force Task Force was able to adapt this unexpected mission through organizational transformation, insurgency collaboration, and the adoption of cutting-edge software applications. This turned Task Force 714 into an intelligence-driven organization capable of analyzing and exploiting big data through state-of-the-art data integration tools. Since the U.S. withdrew from Iraq in 2011, the U.S. Special Operations Command has continued to innovate, adapting an ever-changing war zone in the second decade of the century. And most recently, it has sub-coordinated commands and played important roles in Department of Defense Pathfinders as well. So designed Project Maven, they designed Project Maven, and this was the efforts to kind of, well, at least the original effort was to automate the processing, exploitation, and dissemination massive amounts of full motion video collected by intelligence, surveillance, and reconnaissance assets in operational areas around the globe. The yawning scarcity of human analysts to sort through burgeoning amounts of imagery intelligence, a combination of AI and machine learning, presented an ideal solution. Specially trained algorithms can search for, identify, and categorize objects of interest in massive volumes of data, and flag items of interest. From its initial efforts in Iraq to exploit big data with these kind of methods of AI and machine learning, Project Maven and beyond, also have been key stakeholders in the DoD struggle to transition from hardware-centric organization to one that is software-operated. So through this, the U.S. military was able to use all the data that they had stored to actually use it against Iraq and take down cell towers and to be able to compete in war. So not only are we using big data to get people to buy stuff, and we're using it as an advertising tool, and we're using it in business, but we're also using it in the sense where we are fighting in wars, and we're using other countries' data against them, and using what they have to understand what they're doing, understand where they're going, understand how they operate, and then we use that against them to actually, kind of win the battles. So this is really interesting. As you know, it is a lot of data to sift through, but moving from hardware to software is very, very vital because, to obviously keep up with the other countries as well who are doing the same thing and be able to keep track of all of this data that we have that can truly tell us a lot about other countries, etc. So, the final article that I'm going to read here today is talking about how big data could start a global war, like I was talking about at the beginning of today's episode. So let's get right into that. So this article is by Timothy King. The next big conflict may be fought over something other than land or raw materials, according to Eric Schmidt, chairman of Google parent company Alphabet. In speech yesterday at Google Cloud Next conference, he said, "I think big data is so powerful that nation-states will fight over how much data matters." He added, "He who has the data can do analysis and algorithms at the scale that talked about would provide huge nation-state benefits in terms of global companies and benefits for their citizens, and so on. By now, no one is in the dark about how much of a vital resource data can be. In fact, silent data wars are already being waged beneath the surface between some of the world's greatest power. Data holds incredible value, obviously, and its use is expanding in all ways and means, especially in the public sector. This is evident not only by Schmidt's comments, by the proliferation of available technology offerings that the target organizations outside the business sector. Enterprise companies have been fighting these wars for decades, clawing their way to competitive edge that data could provide. If politics is truly downstream from culture, big data's next battleground is seemingly going to take place in the geopolitical arena. This is serious business, and it's anyone's best guess. And whether data next hurrah is predicting the outcome of hotly contested democratic election or something more sinister. In a 1949 interview with Albert Wiener, Albert Einstein was quoted as saying, "I know not with what weapons World War III might be fought, but World War IV will be fought with sticks and stones." Perhaps the weapon Einstein failed to articulate was big data. I think that is very, very interesting. It tells us a lot about how, it is something that is, obviously affecting, and something that is really prominent that we don't even realize how big these pieces of information are, and how much each country wants it, and how easily threats and wars can be waged. And actually, that's going to take me to this actual final article we're talking about today, which is the U.S. military has been conducting a secret cyber war against North Korea's nukes with surprising results. This was in 2017. So, New York Times report uncovered a secret operation to derail North Korea's nuclear missile program that had been raging for 3 years. I think this was really big in the news. So I'm sure most of you have heard about it, but of course, I will speak a bit about it right now. So essentially, the report attributes North Korea's high rate of failure with Russian-designed missiles to U.S. meddling in the country's missile software and networks. Through North Korea's missile infrastructure lacks the type of confidence of Russia's. Russians using the same type of missiles achieve a 13% fail rate. North Korea attempts failed a whopping 88% of the time, according to the report. But to those in the know, the campaign against North Korea came to no surprise. Ken Gers, a cybersecurity expert for Colorado, the experience at NSA, told Business Insider that cyber operations like this one against North Korea were actually the norm. Well, the fact that the U.S. hacked into another country's missile program may be shocking to some. Within military intelligence bases, this is what they do, Gers said. If you think that a war is possible with any given state, if you're going to prepare for battle next conflict in the internet age, that means hacking. North Korea's internal networks are fiercely installed and not connected to the larger internet. However, which poses a challenge for hackers in the U.S. But Gers said it's absolutely not the case. Computers need to connect to the internet to be hacked. A recent report on the Russian hacking the New Yorker deals with one case in which a Russian gained access to NATO computer network in 1996 by placing bugged thumb drives for sale at local shops near a NATO base in Kabul, Afghanistan. NATO operations bought the thumb drives, used them on the network, and just like that, the Russians were in. That's where the signals intelligence or common communications cooperation with the human intelligence. Gers said it describes the present moment as a golden age of espionage, as cyber warfare remains non-lethal and attributable and almost completely unpunished. But recent missile salvo from North Korea suggests that even a prolonged sophisticated cyber attack can't fully derail North Korea's nuclear missile program. Imagine you're the president. North Korea is a human rights abuser and exporter of dangerous technology, Gers said. Responsible governments really need to think about the way to handle North Korea, and one of the options is to regimen change. Furthermore, Gers said, because of the limited number of servers and access points to North Korea's very restricted internet, if ever came to a cyber war between the U.S. and North Korea, it would be an overwhelming victory for the West. North Korea could do a Sony attack or attack the White House, but that's the nature of cyberspace, Gers said. But if war crime using cyber command wipe out most other countries pretty quickly. So, to kind of end this off, to wrap this up, as we can see, big data doesn't only take us from, kind of exploiting ourselves and getting us to buy a bunch of stuff we don't need, but it also goes to not only fighting in wars and using the power of data to fight against evil, it also uses the power of knowledge to kind of attack other people. It also drives us crazy. It makes us want more data and makes us want to start wars for data. And as well, it has the other side of the coin where it's cybersecurity. And we're trying to protect the rest of the world from, obviously a kind of a crazy country. And we do this by hacking into them and hack in and find their big data. So big data isn't just this buzzword. It is really, really important. And I hope that's what you take away from today's episode. You realize how important big data is, how big it is. It's an ever-growing industry that you can easily get involved with. You'll definitely have a job at some point in the future, since this is only going to become a bigger and bigger issue as more information is out there. So, to wrap up the episode, I please want you all to connect with the social medias. So the Instagram is ever.changingworld. Again, ever.changingworld. The Twitter is everchangingwor. Again, everchangingwor. The website is shows.acast.com/ever-changing-world. Again, shows.acast.com/ever-changing-world. Thank you all so much for listening. Next week will be a great episode. It'll probably be more space related, so if that interests you, definitely tune in. If it doesn't interest you, still tune in. No harm in tuning in. And I want to say that the world is always changing.